Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Carbocation stability is greatly enhanced by aromaticity. A carbocation that, upon formation, yields an aromatic system satisfying Huckel's rule 4n plus 2 pi electrons in a planar, cyclic, fully conjugated system will form most readily. Step 1. Analyze option B. Tropone, cyclohepta 2,4,6 trion 1-1 is a 7-membered ring with a carbonyl. Protonation of the carbonyl oxygen by HClO4 gives a hydroxyl stabilized cation, but the resulting species is the hydroxytropylium cation, cycloheptatrinyl cation with OH, which has 6 pi electrons and is aromatic. This is favorable, but the driving force competes with option C. Step 2. Analyze option C. Tropolone is to hydroxytropon, a 7-membered ring bearing both AC is equal to O and an adjacent OH group with a fully conjugated framework. When treated with HClO4, protonation occurs readily. The key feature is that loss of water, or protonation of the carbonyl, from tropolone generates the hydroxytropylium cation or directly the tropylium type cation. More importantly, tropolone under acidic conditions can lose OH as water to directly form the fully aromatic tropylium cation C7H7+, a 6 pi electron aromatic carbocation, 7-membered ring, 6 pi electrons, 4n plus 2 with n is equal to 1. The presence of both OH and C is equal to O on adjacent carbons of the 7-membered conjugated ring means that protonation and loss of water yields the stable aromatic tropylium cation immediately. This is the most favorable pathway because the product carbocation is fully aromatic. Step 3. Analyze option A. Cyclopenta 2,4-DN1-1 with HClO4 would protonate the carbonyl. The resulting carbocation would be a cyclopentadienyl cation with 4 pi electrons, which is antiaromatic, highly unstable. This does not form readily. Step 4. Analyze option D5 chlorocyclopenta 1,3-diene with UlCl3 would ionize to give the cyclopentadienyl cation, 4 pi electrons, antiaromatic, also very unstable. Does not form readily. Step 5. Compare B and C. Both involve 7-membered rings that can give aromatic cations. However, tropolone C has an OH group directly on the ring adjacent to the carbonyl. Under acidic conditions, HClO4, the OH group facilitates direct formation of the tropylium-type aromatic carbocation by loss of water, making the carbocation formation even more facile than in plain tropone B, where only protonation of carbonyl occurs without direct loss of a leaving group to give the fully delocalized aromatic cation as cleanly. Tropolone loses water to give the aromatic hydroxytropylium tropylium cation more readily because it already has the OH leaving group positioned on the aromatic ring framework. Therefore, the correct answer is C. Therefore, the correct answer is option C.